Welcome to your Business Calculus Lesson 1.4. This time we're going to look at real-world problems using quadratic functions. Okay, if you'll recall, the parent function for quadratic functions is y or f of x equals x squared. Okay, remember there's an axis of symmetry that runs through either the minimum or the point where the minimum or maximum is. That's called the vertex. In this case, it's 0, 0. In general, we call it HK. And the graph of the quadratic is a parabola that is symmetric about that axis of symmetry and that goes through the point of the vertex. When the equation is in standard form, it's written as y equals ax squared plus bx plus c. A tells you whether it opens up or down. If it's positive, it opens up. If it's negative, it opens down. The graph is narrower than our parent function if the absolute value of a is greater than 1, and wider if the absolute value of a is less than 1. The axis of symmetry is x equals negative b over 2a, and the vertex has x coordinate negative b over 2a. And the y-intercept is the point 0c, which is our constant in our function. Okay, we want to graph y equals 2x squared minus 8x plus 6. So first thing we need to do is identify the coefficients. So a is 2, b is negative 8, and c is 6. We know it opens up because a is greater than 0. We want to find the vertex. First thing you do is you calculate the x coordinate with the negative b over 2a, and plugging in our values, we'll have what simplifies to be 2. And then to find the y value, you simply plug in the 2 for x and simplify. And when we do that, we get negative 2. All right, on your graph, you want to plot that point, and then you want to draw the axis of symmetry, which is going to be x equals 2, the vertical line through the vertex. All right, the next step would then be to identify and plot the y-intercept 0c, which is the point 0, 6. Then reflect this point across the axis of symmetry to plot another point, 4, 6. So that makes life really nice. We know that 0, 6 is a point, like 2, 4, 6 is a point on our parabola. The axis of symmetry isn't just named that for fun. It actually is an axis of symmetry, and you get your other point. And then you want to pick another x value, such as x equals 1, evaluate that. We get y equals 0, so at x equals 1, y is 0, and then we can plot its partner from symmetry, 3, 0, and that gives us the 5 points we need to be able to graph a quadratic fairly well. And so we just draw our nice smooth quadratic through those points. Remember, even though there's a minimum, or there could be a maximum, it's not pointy. We don't have two line segments meeting at that vertex. It's a nice smooth curve. Okay, so if A is positive and it opens up, there is a very bottom point. It's like the bottom of a valley, and the function value there is the minimum. And if A is negative, there's a hilltop, and the function value, the y value at that where the hilltop is the maximum. Unless it's stated otherwise, for some reason, the domain of a quadratic function is all real numbers. Sometimes, though, in real-world cases, we have to limit ourselves to non-negatives. So you have to consider the context. Depending on the sign of A, the range will either be all real numbers greater than or equal to the minimum value, or all real numbers less than or equal to the maximum value. And then again, when we're working with real-world problems, we have to consider what makes sense. Sometimes you can't have negative values. All right, we want to tell whether the function y equals 3x squared minus 18x plus 20 has a minimum or a maximum value, then find the minimum or maximum value. Well, since a is 3, that's positive, so it opens up, and so it's going to look like a valley, so you're going to have a bottom to your valley, and so you want to calculate the coordinates of the vertex, and the y value of the vertex, the function value of the vertex will be your minimum value. All right, so first thing we do is we figure out the x value, which is negative b over 2a. So we have negative 18 over 2 times 3. So negative times negative is positive. 18 divided by 6 is 3. To find the minimum, the y value, we plug that 3 into our original function for x, and we simplify and we get negative 7. So the minimum value of our function is negative 7. All right, if you want to check with your graphing calculator, here are the instructions for finding extreme values with your CAS. I'm just going to go through them quickly. Probably what you're going to want to do is work through that problem using your CAS. Feel free to pause this right now. Basically, you're going to enter the equation in F1, first little function place. You're going to press enter. You've got to make sure you can see your max or min. Otherwise, you need to adjust your window. You're going to go to analyze graph. You need to tell the calculator whether you want a maximum or minimum. You just look and see what you have and see which one you need. And you're going to kind of do the same process we did when we were finding intersecting points of two functions. You're going to pick a lower bound and then go to the right until you pass the maximum or minimum, and then you'll pick an upper bound, and then you'll press enter. Remember, even though you're going to get the coordinates of both points, what you are interested in is negative 7. And just to give you a note, I did have to adjust my window to see the coordinates. So it would be worth your time to go ahead and pause this, grab your CAS, put this function in for F1, and work through the process. Okay, great. Another helpful form is called Intercept Form, and it is the form y equals a times x minus p times x minus q. The x-intercepts are p0 and q0, so that gives you 2 points. The axis of symmetry is halfway between p0 and q0. It has the equation x equals p plus q over 2. So that also means that the x value of your vertex is equal to p plus q over 2. That's going to give you the same thing as you would get if you did negative b over 2a in standard form. A, as always, tells you whether it opens up or opens down. If A is greater than 0, it opens up. If A is less than 0, it opens down. All right, we want to graph y equals x plus 3 times x minus 1. We want to first note that the intercepts, the x-intercepts occur at the points negative 3, 0, and 1, 0. Remember, you have to set each one of these equal to 0 to see what the intercepts are. That's probably the easiest way. Or you have to consider that the form is x minus p times x minus q. So this is x minus negative 3. So p is negative 3. And this is x minus 1. So q is 1. You want to find the coordinates of the vertex. So we always have a little formula to find the x value of the vertex. In this case, it's p plus q over 2. And so we get negative 3 plus 1 over 2, which is negative 1. Now, you may be thinking, well, could I just multiply, could I FOIL out my x plus 3 times x minus 1 and then distribute the 2 and use negative b over 2a? You can. It's going to give you the same exact value for x. All right, so to find y, we're going to do what we did before. We're going to plug in negative 1 for x and simplify, and we get negative 8. And here's our lovely parabola. If you wanted to get more points, you could just pick a value like 0 and plug that in and find out what value the y value is there, and then reflect it across the axis of symmetry to get the 5th point. But on this one, the 3 points does a pretty good job of showing us how to graph our parabola. All right, so we want to look at real-world applications. We're going to look at all kinds of them in your problem set. Let's look at this one. The path of a place-kicked football can be modeled by the function y equals negative 0.026x times x minus 46, where x is the horizontal distance in yards and y is the corresponding height in yards. So x is distance, how far it was kicked, and at any point in time, the y value is going to tell you how high it is. So how far is the football kicked, and what is the football's maximum height? All right, for the function y equals negative 0.026 x times x minus 46, p is 0 because x is the same thing as x minus 0, and q is 46. We have x minus 46. And the x-intercepts are 0, 0, and 46, 0. So you conclude that the football is kicked a distance of 46 yards. It starts off on the ground, and it lands on the ground. At both those times, the y value is 0. And so the one logic dictates that it's not at 0, 0. We didn't kick it 0 feet. We kicked it 46 feet. To find the maximum height, calculate the coordinates of the vertex. So halfway between 0 and 46 is 23. And then we plug in 23 for the x value, and we get about 13.8. So the maximum height is the y coordinates of the vertex, or about 13.8 yards. All right. So we have a lot of business applications. So let's look at this one, that revenue is equal to price times demand. Remember, revenue is the total income received. If Q items are sold at P dollars per item, then the revenue from this sale is R equals P times Q. In other words, if demand is Q and the price is P, revenue is price times demand. So the Better Baby Buggy Company predicts that the demand for its new model is Q equals negative 2P plus 320, where Q is the number of buggies and can sell them in a month if the price is P dollars per buggy. So we want to find the revenue function. So our revenue function is going to be P times Q. So we're going to have P times the rule for Q, so negative 2P plus 320. So negative 2p squared plus 320p, where R of p is the monthly revenue when the price is p dollars. Okay, would this function be in standard form or vertex form? Or intercept form? Well, since you can see the p squared term and the p term there, this is in standard form. So just for the sake of talking about it, A would be negative 2, B would be 320, and C, our constant, would be 0. So just helping you kind of analyze what you would do from there. If we were finding the vertex of this, we would do negative B over 2A for the x value or the p value, and then we would plug in that value for p and figure out what the revenue at that price would be. Okay. That is it. Go ahead and do what you can on your problem set, and then we'll pick up and work from there in class. If you have any questions, you know how to find me. Thank you so much for watching the video, and I hope you have a good day.